Hello everyone. Today we'll be discussing R and S configurations of one stereocenter. Before we proceed, let us define the meaning of stereocenter or chiral center. By definition, a stereocenter or chiral center is a center bearing 4 different substituents, while the carbon atom that holds the 4 different substituents is called a stereogenic carbon. Let us consider this compound 2-chloropropane. If you have a look at this compound, you will notice that this carbon atom, marked as asterisks, contains 4 different substituents, which are the chlorine, the methyl group, the ethyl group, and the hydrogen. Therefore, this carbon center is called stereogenic carbon. So we can likely say that 2-chloropropane contains a stereocenter, which is a center that contains all the 4 different substituents. Let us consider another example, 2-methylbutane. If you analyze the structure of 2-methylbutane, you notice that 2 groups are identical. That is, the 2 methyl groups are identical. So because you have 2 groups that are identical, this compound is not regarded as a stereogenic center because all the 4 substituents are not different. The 2 methyl groups are identical. Having a good knowledge of a stereocenter, that is, knowing what a stereocenter is, we can now proceed to determination of the configuration of a stereocenter. In determining the configuration of a stereocenter, the 4 different substituents are ranked in order of atomic number. That is their priority. If you have a look at this, at this example or illustration, you will notice that fluorine has higher atomic number than oxygen, and oxygen has higher atomic number than nitrogen, while nitrogen has higher atomic number than carbon. Down the group, you notice that iodine has the highest atomic number compared to fluorine. So these 4 different substituents, you rank them based on the atomic number. The one with the least atomic number is given the least priority, while the one with the highest atomic number is given the highest priority, which is 1. Let us consider butan-2-ol as an example. This is the 3D structure of butan-2-ol. So we are going to assign priority to this compound based on the atomic number of the elements present in the compound. In assigning priority to this compound, the oxygen is the one with the highest atomic number. That is why it is assigned priority 1. Then the ethyl group is the second in priority, and the methyl group is the third in priority. The hydrogen is the least in atomic number, and that is why it is assigned priority 4. Another important point we have to derive from the 3D configuration of this compound is the element with the least priority, which is hydrogen, is in dash, while the element with the highest priority, which is oxygen, is in wedge. So for this reason, we have to assign the configuration moving from the one with the highest priority to the second priority and to the third priority. The position of the element with the least priority is insignificant since it is in dash. So in assigning configuration to this compound, we have to consider which direction is the arrow moving. If you are moving in a clockwise direction, then the configuration becomes R. While if you are moving in anti-clockwise direction, then the configuration becomes X. So with regards to this compound, the configuration of this compound is S, and the complete name is S-butan-2-ol. That is the configuration of this compound. Another important information we can derive from this compound is if the hydrogen, which is the element with the least priority, is in wedge instead of dash, then the configuration of this compound will be reversed to R. This is because you have to rotate the compound through 180 degrees to put the hydrogen from wedge to dash. That is why you have to reverse the configuration if the hydrogen with the least priority is in wedge instead of dash. In terms of bond priorities, that is another way we can actually assign priority. Whenever we encounter carbon to oxygen double bond as in carbonize, it means carbon attached to oxygen and is attached to another oxygen. Then carbon to carbon triple bond simply means 3 carbon atoms, while carbon to nitrogen triple bonds as seen in nitrides means carbon with 3 nitrogens. Let us consider this compound. We are going to assign priority to this compound based on the atomic number. So based on the atomic number, oxygen is given priority 1, then carbon to carbon double bond is given priority 2, while carbon to hydrogen is given priority 3, then hydrogen, which is the least in priority, is given priority 4. So carbon to carbon double bond is given priority 2 over carbon to hydrogen bond. This is because in carbon to carbon double bond, as earlier stated, we have carbon linked to another carbon. But here in position 3, we have carbon linked with 2 hydrogens. That is why carbon to carbon double bond is given priority 2 or higher priority over position 3. In assigning configuration to this compound, we move from priority 1 to priority 2 down to priority 3. The position of priority 4, which is the one with the least priority, does not actually matter. So this compound, the actual configuration of this compound is S configuration. Let us consider this example. We can assign priority based on atomic number. Chlorine is given the highest priority because of higher atomic number, followed by fluorine, then followed by 2 carbons. The third carbon has 2 alkyl groups and this one has just 1 alkyl group. So this is isopropyl group and this is ethyl group. So that is why it's isopropyl group is assigned position 3 and this 4, which is the ethyl group, is assigned position 4, which is the least priority. If you observe this structure, you will notice that the one with the least priority is not in dash, which is position 4. Rather, it is in a straight line or straight bond. So we have to rotate this molecule through 90 degrees so that the one with the least priority will be in dash. After the rotation, we have observed that the one with the least priority is now in dash. Then we can now assign our configuration by moving from the one with the highest priority to the one with second in priority. The information we can derive from this example is rotation through 90 degrees does not change the configuration of the compound. If you observe the initial structure, the initial structure is still S configuration. The only difference between the initial structure and the final structure is that the one with the least priority is in dash in the final structure, but the configuration does not change when the rotation is through 90 degrees. Let us consider another example. In this compound, we are going to assign configuration based on atomic number. The oxygen is assigned priority 1. The tertiary butyl is assigned priority 2, while the carbon or the allylic position is assigned priority 3, while the ethyl position is assigned priority 4, which is the least priority. If you observe this structure, you will notice that the substituent with the highest priority is in dash, while the substituent with the least priority is in wedge, and we don't want that. So because the substituent in the least priority is in wedge, we are going to rotate this compound through 180 degrees to put the substituent that is in dash. We are going to rotate this compound through 180 degrees to put the substituent that is in wedge to dash. That is when we can actually know the right configuration of this compound. After rotation through 180 degrees, we now have the substituent with the least priority in dash, which is at position 4, and the substituent with the highest priority in wedge. So here now, we can now assign priority starting from the one with the highest priority to the second in priority and to the third. Like as earlier stated, the position of the one with the least priority is insignificant. Therefore, the correct configuration of this compound is R configuration. In my next video, I will be discussing R and S configuration of more than one stereogenic center, that is 2 or 3 stereogenic centers. Please, if you enjoyed what you watched, like, subscribe and share. Then if you have any question with regards to this video, please leave your comments in the comment section. Thank you so much.